So we will be solving rational equations, and these are the 3 steps on your screen. Now the thing about the rational equation is that each side of the equation must be a single fraction like this, but not this. And so we will proceed to number 2 now in the first example, since both side of the equation is a single fraction. Now we will cross multiply. The reason for cross multiplication is that we want to remove the fraction, because in most cases it's very hard to deal with fractions. So 4 multiplied by x minus 8 is equal to 5 times x plus 7. And then we distribute 4 and 5, and that will be 4x minus 32 is equal to 5x plus 35. So we want to isolate x, so we have to remove first negative 32 by adding it on both sides of the equation. And so that we have now 4x is equal to 5x plus 67. And then we remove 5x by subtracting it on both sides. And so you have 4x minus 5x is negative 1x. You don't need to write it, but I will write it anyway. And then, of course, x should be positive. And so we divide each side of the equation by negative 1. And that makes x equals negative 67. And of course, if you want to find out if our answer is correct or not, we can use Desmos. So these are the strategy for Desmos. The left side of the equation is y equals x minus 8 all over x plus 7. And then y equals 5 over 4. Alright, now we have to identify the point of intersection. And as you can see, it is at x equals negative 67. And so I'm going to leave this for you to practice. Now let's proceed to here. So this side of the equation is not a single fraction, so we need to combine it by using the butterfly method. So that was actually discussed to you in our previous lesson. And so we know that the denominator of 9 is 1. And so therefore, I'm going to insert first a fraction. All right. And so therefore, 6x times 1. So we go down first and then go up. And so you have 6 times 1 is 6x minus, okay, now we go to up. So 9 times x minus 9. And then, of course, both denominators, 1 times x minus 9 is x minus 9. Is equal to the same fraction, and that's 3 over x minus 9. Now we can actually cancel x minus 9, but I'm going to show you that it's actually like a legit method to do that. So before that, we can distribute negative 9 to x minus 9. So I will just copy. So that's easier for me. So you have x minus 9. Alright. So you have negative 9 times x minus 9 is negative 9x plus 81. Alright. So we will combine like terms. I'll copy it again so that it's easier for me. Oops. Alright. Okay. Combining 6x and negative 9x will give us negative 3x. And so therefore, we have a single fraction on each side of the equation. I can do cross multiplication. And that gives me negative 3x plus 81 is equal to 3 times x minus 9. By the division property of, times x minus 9. Sorry about that. Okay, now, by the division property of equation, we can just divide x minus 9. And so that leaves us to negative 3x plus 81 is equal to 3. So as you can see, we can just cancel the denominators if they are the same. If they are not the same, of course, you cannot do that. And so we will subtract 81 on each side of the equation, and that's negative 3x is equal to negative 78. Okay, and then we'll divide negative 3 on both sides, and so x equals positive 26. And so let's check if our answer is correct or not. And so y equals the whole side of the left side. So that's 6x divided by x minus 9 minus 9. And then y equals 3 over x minus 9. So as you can see, the point of intersection at x is positive 26. Now we'll proceed here. So first step, since I already have copied the fraction, I'm just going to copy that so that I have a fraction here. All right, now, so the denominator of x here is 1, so down and then up. So x times x plus 3. Okay, then minus, all right, 1 times x plus 2 over x minus x plus 3 is equal to 1 over x plus 3. Okay, so we have proven already that if you have the same denominators on each side of the equation, we can just cancel the denominator. So that would leave us to, I'll distribute already, x times x is x squared. So I'll insert here. Okay, so that's x squared. Okay, plus 3x. Okay, now distribute negative 1, so that's negative x. Okay, minus 2 is equal to 1, which leaves us to a quadratic equation. And you know, in a quadratic equation, our equation should only be equal to 0 and it's equal to 1. So first we combine like term here. So I'm going to copy this so that it's easier for me. Okay, so 3x minus x gives us 2x. Then after that, we subtract 1 on each side of the equation. That will leave us to x squared plus 2x minus 3. And this is actually factorable by quadratic trinomial on the first example, and that's factoring negative 3 in order to give a sum of 2. So that will be x plus 1 or plus 3, and then x minus 1. So you see plus positive 3 plus negative 1 is positive 2, and 3 times negative 1 is negative 3 equals 0, which gives us the value of x to be negative 3 and x equals 1. Now remember, in our original equation, our x here cannot be negative 3, otherwise it becomes undefined. So x equals negative 3 is a restriction for x. So therefore, our final answer is that x is only equal to 1 because this doesn't make the equation undefined. So let's see really if that's really the case using our Desmos. So you have y equals x minus x plus 2 over x plus 3. And then y equals 1 over x plus 3. Let's see if it's really if it's just really 1. That's the intersection of your equation. And that's really it. Okay, x equals 1. And the other solution, which is at negative 3, is not part of the solution of the problem. It seems to me that it is a vertical asymptote. Okay. And so, I'm going to leave it to you guys. This example here to practice, and this example here to practice, hopefully by hand method and by using your Desmos. And then, of course, you proceed to your delta math on rational equation. So if you go to your delta math here, all right, okay, so here is a rational equation. There are 3 here. Now it's up to you to decide which method you would like to use. You can use the hand method or you can use the Desmos method. Good luck to you guys.